Unit 4.4, if statement. So that's what we'll be looking at, and then I have a number of examples to walk through with the if statements. So first off, an if statement came from the selection. Remember, with sequential, selection, and repetition, this is known as a single selection. It's called a single selection because the if statement, which is a block, okay, code occurs in block. All code are inside some block. So it's a block, and this block starts with an open curly here, ends with one there. The code to be executed is going to be inside the block, whereas the indentation. This condition is a Boolean expression. It's called single selection because it only going to run this code or execute it if the condition is true. So we are selecting whether we are going to run this code or not. Because if this is false, this code does not run. See, the if statement says, check this condition, see if it's true. Whatever that statement is, a Boolean statement like we've seen before up here. If it turns out it's true, do this. If it turns out it's false, skip this block. Okay, so a single selection. I have a number of examples here, and I'm going to start off by looking at them each in turn, and I have the others all commented out, and then we'll explore them as we go down. If you could remember, earlier on we had x and y as 10. I'll go back and show you we had those two as 10 when we were writing our Boolean expressions. All the way back here, further up right here. Okay? We had x and y as 10. So right now I'm going to write some if statements based on the fact that x and y are 10. So the first statement I see here is an equal to. Okay, well, it's a double equal. That stands for the equal to for Boolean. Okay, it's not a single equal. Remember, this single equal is an assignment. See, you get an error there? That would have been take y and assign it to x. That's not a Boolean expression. The double equal is the Boolean expression. So I'm asking, is it true that the value that's stored in x is the same or equal to the value that's stored in y? Currently, the answer is yes, it's true. So if I run this, and I'm about to do that, it would print x and y are equal. Let's go down, see it right here. Because it's true, x and y are equal. So it's going to print that. Second example is if x is not equal to y, print that x and y are not equal. Well, let's check. This condition is false because x is 10 and y is 10. So by asking, is it true that x is not equal to y? No. So it's going to skip this. I'm going to run it again. See, we're going to look for that statement and nowhere to be found. X and y are equal. That's this one. And it never printed x and y are not equal because it's not true. All right, the next example asks, is it true that x is less than y? No. So this would not print either. So run that again. You will only find that x and y are equal. See, no other print. This printed. This one prints. This one does not print. This one does not print. So that's why it's called a control structure, because you could control whether this thing happens or not. All right, so now let's go to example 4. See, now we're talking about doing a little bit of code that changes the value of x and y. See, if I'm looking at this right now, it's not printing anything. It's just updating the values of x and y. So it says, is it true that x is equal to y and x is less than 20? Remember, and both gotta be true. They're both 10, so this is true. 10 is less than 20, so this is true. This whole thing turns out to be true. So then x and y are about to change. It says take the x, okay, add on the y, and store it back as x. So they're both 10 right now. So when we do that, x will now be 20. Because we took the 10, add on a 10, store that back as 20. Next one says, take the x, okay, what it is now, that's the 20, because it changed, multiply it by what y is 10, and then store it in y, so y should become 200, right, because we take 10 times 20. So now, we come upon another if statement, right, so we come upon another if statement here, and this is asking, is it true that the y is greater than x after this is finished, okay? We're going to get to what these two if statements on top of each other is called later, but right now we have two of them, two if statements. We finish with this if statement, it comes here, it checks this one, and let's see if it prints y is greater than x. It should, because it's 20 is 200 is definitely greater than 20, right? So let's see if that works. Y is greater than x, see? So when we write in code, we could use if statements to control what prints, what does not print, what goes on, what doesn't go on. Very powerful. Moving on to example 5. Now keep in mind that x and y just changed, okay? So when we get to this point, we're dealing with x being 20 and y being 200. Is it true that y, 200, is greater than 20? Yes. Or x is greater than y. Well, x is not greater than y, but it doesn't matter. It's an or. Only one has to be true. See, and the both have to be true for it to run, or only one has to be true. So this 200 greater than 20 makes the statement run. Short circuit. Short circuit. What that means is the minute this is true and it sees an or, it ignores this. Doesn't even check that. No need. Because once it's true and it's an or, the whole thing's true. So let's see if that prints. Let's look down. Yep, x and y are not equal. See, make sure we get that in view. X and y are not equal. That prints because this is true. It's an or, whole thing's true. We enter the if statement. Once this statement is true, we follow whatever is inside here. Next example is now example 6. It says, if not y is less than or equal to x and x is less than or equal to y, well, this is a little convoluted, confusing thing. So what do? We distribute the not. And if I distribute the not here, that would get me y is less than x. Distribute the not there, that'll get me or. Distribute the not here, that'll be x is not less than, said the wrong thing here, greater than. And then this one will be x is greater than y. So let's make sure we get that correction. Greater than, because it's less than, so we want to shift the sign. So not turns that sign around from less to greater, and not turns this around from less to greater. So once you do that, what you realize is this statement is the same as the guy above. This convoluted looking thing here is exactly this. So you see, when you get these types of situations where you have a not, then a nice distribution could make it a lot simpler. De Morgan's laws. Let's run this and see what happens. Okay, so print it again. Clearly, they're not equal. So that's literally how an if statement works. However, there are a couple of little things we have to take a look at. The first is if you have one statement inside the if block, one, only one, you don't need the curly braces. If you have one statement. Now let me just say something about this. realize the indentation. Realize it's not over here. Okay, that's bad style. You want to be indented to show that this one statement is inside the if. Meaning the curly braces here, we're just not putting them because it's not necessary if it's one. So I will never ask you questions where I run these types of tricks here, but realize that this is one statement inside this if, but there are two statements inside this if. I can't do this. I mean, I can. And some professors would make this a little trick. You see, the problem with this is that this is the only statement inside the if. This one is not inside the if. And that's not a good trick. That just is a little mean there to write that. So I will never do that to you. So the intent here is not to trick you or anything, but to let you know that if you don't see the curly braces, if you don't see curly braces for the block for the if, the only statement that's inside that if is the very first one. I could have 10 different statements out here. The only one would be this. If you want them all in, put the curly braces back. Okay, so that's something that I would not trick, but something to know that in case you see some code without a curly brace, you know exactly what it's doing. And that's not just true for the if statement, it's true for every block, as we'll see as we go through more control structures. So yes, for this number 3, we don't need the curly braces. Now, I tend to leave them sometimes because it helps me organize in my mind how my code looks. Some people don't like them if they don't need them. You can choose. Choose to put them if you need. Don't put them if you feel like you don't need to put it. Now, the if statement is not the only control structure. It's just one of the 3 selection structures. So if you think about it, in all we have 7. We have the sequential one, the 3 for the selections, and 3 for the loops. That's 3 plus 3 plus 1, which is 7. That's all we have in computing. So imagine bits, just 2, 0 and 1. 7 statements. That's it. Types of variables. And that is all we have. And we could write every possible program that we need from that basic small set. Very similar to saying the alphabet is used to make words. The words are used to make sentences. Sentences make paragraphs. Paragraphs make essays or stories. And you can see how that builds out. And then before you know it, you have a book, right? So same thing here. We have a very small set. 7 blocks for control, step by step. Okay. In the absence of these control structures, every piece of code occurs step by step, and I'll show you that up here. So when we were writing these things, see, these are step by step. This goes first, this goes next, this goes next, this goes next, and so on. So this step by step is inherent. It's like it's very common in terms of it's always there. But then we would have this control structure where we will change the steps. Okay, we're changing the steps. So when I see these coming down like this control, sometimes this might run, sometimes this might run. So it's not necessarily going step by step. Okay, that's the idea of the control structure, is that I can control which line of code runs, which one does not run, and so it's not straightforward anymore. Okay, it's not a straight line anymore. And that's what I was speaking about. Being able to think non-linearly. So this effect we'll see more. And again, this condition here has to be a Boolean condition that would allow you to evaluate true or false. It's true, code runs. It's not true, code does not run. Now I have some simple if statements here, but as we go on, we'll have to write some more complicated ones because we may need to do a lot more inside the if. But right now it's just a quick look at how the if statement looks, how it works, how it executes. That's all. And that brings us to the end of 4.4.